Hi, in this video we're going to define fully what we mean by x to the power n, other than the special case 0 to 0. You might think this is trivial, it's just x multiplied by itself n times, and that's true for if n belongs to the set of positive integers. But what if it doesn't? Well, we've already proved in episode 4 that if n equals 0, then x to the n equals 1, provided that x is not also 0. Since in the derivation we assumed x to the n divided by x to the n equals 1. Whereas if x equals 0, we get 0 to the power 0 over 0 to the power 0, which is not necessarily equal 1. We've also defined that x to the minus n equals 1 over x to the n. So we've got x to the n defined for n belongs to a set of integers. What if x is a fraction, or if it's irrational, which means a number that can't be written as a fraction? We want a definition of x to the n for n is any real number. Well, first it might help to define what the inverse of raising x to the power n is for n belongs to a set of integers. Say x to the n is equal to a. If we can find what x is in terms of a, then we know what the inverse of raising x to the power n is. So we can apply it to the x to get we can apply it to the x to the n to get x. We might be able to notice what the answer is. Since x to the n is x multiplied by itself n times, then the inverse must find what number multiplied by itself n times gets x. If x equals b to the 1 over n multiplied by itself n times, we get b to the 1 over n multiplied by b to the 1 over n multiplied by b to the 1 over n, and so on, n times. This can then be wrote b to the n over n equals b to the 1 equals b. So raising something to the power 1 over n is the inverse of raising something to the power n, which is n. So b to the 1 over n means what number multiplied by itself n times equals b. Well, now we've got x to the power any fraction defined, we can say x to the m over k for integer m and k. And we know this means find a number that multiplied by itself k times equals x, then multiply that number by itself m times. So now just say n is equal to m over k. We have x to the n for n belongs to the set of rational numbers defined, where rational numbers just means any fraction with an integer top and bottom, and it's signified by this little q symbol. Well, now the real numbers are constructed in such a way that an infinite sum of rational numbers can produce any element of the set of real numbers, so it can produce an irrational number. So we've managed to define x to the n for n as a rational number. We can just set n as an infinite series of rational numbers. We can now define x to the n for n as any real number, other than the special case 0 to 0. Let's take an example just to demonstrate. So let's figure out what 4 to the power minus 3 over 2 is. Well, first we know that the minus just means 1 over the whole thing. Let's do that to get 1 over 4 to the power 3 over 2. Now we know the over 2 bit means what number multiplied by itself gives 4. But I think you can probably tell that 2 multiplied by 2 is 4. So we can now get 1 over 2 to the power 3. What is 2 multiplied by itself 3 times? Well, 2 times 2 times 2 is 8, so we've got the answer is 1/8.